Hello, this is the demonstration for the fpgascope. This is the latest build. There's a few bugs, but like most of the technical specifications are working. It's just we ran out of time for fixing things like this. These are pretty easy fixes that can be solved after the project presentation. Anyways, we have three main screens. We have a main screen here. There's a clock and a bill number. We have the waveform screen, which displays all our information. I'll come to that in a second. And we have a help screen with our keyboard shortcuts. This is in all of them because I did not have time to update them, but again, this is a really easy fix. Q goes back to the waveform menu, and Q goes back to the start menu. If I press H here, I go into the help menu, and I can go into the help menu here. I can't go back into the waveform screen unless I exit, so it's pretty intuitive. Anyways, okay, here's my waveform screen. This is my trigger level, so this is how I trigger my wave so that it doesn't keep scrolling across the screen. This is my voltage scale, my time scale. This is my channel selection, and I can turn them on, as you can see there. I will turn them on in a second. This is my cursor selection. There's a missing C again. That is a bug fix we can have later. These are the per channel time and voltage offsets. This is the cursor's position, the difference between their positions, and of course the Y position. And then this here, oh actually that's wrong. That's fine. This should say Vmax, Vmin, peak to peak, period and frequency. The period and frequency aren't currently working as there was no time left, but these should be correct and scaled accordingly to the source's amplitude. Anyways, let's go turn on some channels. So I'm turning on that's channel 1. There's actually no voltage applied right now. Here's channel 2, 3 and 4. And as you can see, 4 has a signal applied. Let's quickly change channels if you just come here. Currently I'm on channel number 4, but I can change to channel 2. So you can see now there's no display. And the reason why it displays up there is because we have a vertical voltage offset. So that's, again, let's go to the green channel. I can display the green channel. Let's switch over to another channel. Here's the blue channel, and here's the red channel. Anyways, I can reset my screen so that I don't have to wait. Let's just stay on the red channel for now. So the main consideration here is, first of all, it's scrolling because I haven't triggered anything. So my alternative method is just to simply pause the waveform. R is to pause the waveform, and I've now paused it. The oscilloscope is actually just generating a waveform for me. And I'm currently generating a waveform of 500 millihertz. The current time base is 500 milliseconds, and there's 10 divisions, so per division I have 500 milliseconds. This entire scale here is 500 milliseconds or 5 seconds, and since the waveform frequency is 500 millihertz, we should be seeing 2.5 waves on the screen. So we have 1 wave, 2 wave, and a half wave here. So that makes sense. If we unpause and increase the frequency to, let's say, 1 hertz, we should see the scroll is faster because this is actually coming in straight from the ADC. We aren't batching any signals as we were before. And let's say we change the time base to 200 milliseconds. So that means this entire thing is 2 seconds across, and we should be seeing 2 waves, which we are 1 and then 2. We can go up to around 25 kilohertz, which is actually 1/2 of 50 kilosamples per second. But just for interest, let's go up to 46 hertz, 46 kilohertz, sorry. And you see here, if actually we have to zoom in a bit, and we can see a wave here. Yeah. So if we zoom out, we can also see this other wave here. So this wave is actually, because of the aliasing, each of the 400 vertical slices here are being drawn from the from our buffers. And this aliasing happens is because we're decimating some of our samples, and because of that we are actually losing detail here. More precisely, it's actually we're changing the ADC sample rate by increasing the time between our samples, which fills our buffer slower. That's why at higher time bases it scrolls slower. But the other thing is, because of us sampling at having a gap between sample times, we actually lose data. We lose a lot of data. So it looks somehow like a sine wave, but that's not the real sine wave. This is a really zoomed out version of the real sine wave, and we zoom in, we can actually see it at 500 microseconds. Okay, you can pause. Multiple trigger modes. There's a rise and a fall. There's an auto, a single, and a normal, which are implemented. Only the normal trigger is working, and the rise and fall, of course, is working fine. Yeah, I can move my, so let's go select the red wave, and I can move my wave up, I can move it down, I can move it left, right. I can switch to the trigger menu, I can turn on my triggers. This is my cyan triggers here, and these are my magenta triggers. I can move them again using the same keys, right, left, up, down, and of course I can move these triggers, sorry, cursors, these are cursors, not triggers. There you go. I think there's anything else to it. Oh yeah, I can change the voltage scale. So if you unpause, we can make the voltage scale smaller. And right now it's actually clipping outside. So let's go move it in. We can move the entire wave in. It's a bit, so it's down there right now. So let's go back to a higher wave. So it's right there. I'm gonna move it up, and then I'll change the voltage scale so we can actually see what's happening.
Done?
Almost. Just
Thanks.
it's fine. Like, might as well have all the features. Okay, there. So now we can see the wave it was clipping before. Okay, that's it.